So, people, good evening and welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, having a good time. So, can you quickly let me know in the charts if all of you can hear me, if I'm perfectly audible and visible to every one of you? Let me know in the charts with some fire emojis, quickly. Let me know quickly, people, in the charts if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly, let me know in the charts. Welcome back, people, welcome back. So finally, we are starting the NEET 2025 series on this particular channel, your Unacademy NEET English channel. And my dear students, today I shall be starting with the first chapter of our class 11th chemistry, and you know it, so it is going to be the mole concept. It is going to be the first session of the chapter mole concept. Before starting this particular chapter, let me tell you, this particular chapter, the epic mole concept, it forms the foundation of your physical chemistry. My dear students, trust me, if this chapter becomes strong, your entire physical chemistry is going to become strong. If there's a problem in this chapter, there will be problem in the entire physical chemistry. You should know it by now. Yeah? And people, this particular chapter I shall be exactly completing in 3 sessions. Right? I will be taking 3 sessions of this particular chapter because every single thing will be touched in detail. Every single topic will be discussed in detail. All the theory, all the problem patterns which are included in this particular chapter, every single thing I shall be covering from the basics, from the scratch. So are you all ready for this infinity series, people? Let me know quickly in the chats. Are you all ready for this infinity series, which is particularly designed for all the NEET 2025 aspirants? Let me quickly know in the chats. Yeah? Let me see the Josh of the session first, and then we shall be starting the session. Right? Let me see the Josh of the session first, then we shall be starting the session. As I told you already, every single thing I'll be discussing in detail, from the basics, from the scratch, as if you have never studied this chapter before. Perfect. So all the NEET 2025 as well as NEET 2026 aspirants can watch this particular session. And my dear students, one thing I would want from all of you, what is that? I would want you guys to take the running notes. Whatever I'll be mentioning on the screen, I would want you guys to take a note of every single thing, right? Every single thing has to be noted down. Perfect. And when I'll be writing things on the screen, you'll be at the same time writing things in your notebook as well. Perfect. Perfect, guys. All right. So before starting this particular session, let me exactly tell you what all things, what all topics are there which we have to cover in this particular chapter. And before starting exactly, the ones who have not liked the session yet, I would want every one of you to smash that like button, mark your attendance. If you have not shared this particular video yet, do share this particular video with everyone. Let every NEET 2025 aspirant get benefited out of these free lectures and the quality lectures which you can find completely in English language on YouTube, right? And at the same time, the ones who have not subscribed to the channel yet, I would want every one of you to subscribe to the channel right now so that you remain updated about all the sessions which we are planning to take on this particular channel. Yeah? So before starting the chapter, let me quickly show you the summary of what all topics are there in the chapter which we shall be completing, right? Let me show you the sequence of the topics which we shall be covering, right? So my dear students, we shall be starting this particular chapter with the basic terminologies. the basic terminologies which are involved in the chapter mole concept, we shall be starting from them. We shall be starting from the basic terminologies. Number one. Number two, what exactly we shall be doing? We shall be talking about the average atomic mass. We shall be talking about the average atomic mass of isotopic mixture. Isotopic mixture. This is one more important topic from which question frequently comes. This is going to be the second discussion, right? Average atomic mass. Then, my dear students, I'll directly go to the calculation of moles. Calculation of moles. This is going to be our third topic, right? This is the sequence which I'll be following basically. And I would want you guys to take a note of this sequence as well. Okay? So it's going to be calculation of moles. Just a second. Okay. Calculation of moles. After doing the calculation of moles, I shall be showing you the mole conversion diagram. I shall be showing you the mole conversion diagram, with the help of which you can easily solve some of the basic questions which are there in the chapter mole concept. After doing the mole conversion diagram, we shall be discussing the calculation of atoms, electrons, protons, neutrons, ions, as well as valence electrons. This is going to be one more topic which we shall be covering, right? Calculation of atoms, electrons, protons, neutrons, ions, and valence electrons. Well, after discussing this particular topic, I shall be moving into the calculation of moles of atoms and molecules. Calculation of moles of atoms and molecules. This is going to be our one more topic, right? Calculation of moles of atoms and molecules, right? After discussing this particular topic, we shall be talking about the average molar mass. We shall be discussing about the average molar mass of a gaseous mixture. Average molar mass of a gaseous mixture. This is our one more topic, one more important topic, right? After doing the average molar mass of the gaseous mixture, what exactly we shall be doing? We shall be discussing about the term vapor density. And after the vapor density, we shall be discussing about the percentage composition. Once we are done with percentage composition, then we shall be starting with the most important topic, that is stoichiometry. Stoichiometry. After stoichiometry is done, after we discuss the stoichiometry in case of simple reactions, then we shall be talking about the stoichiometry involved in sequential reactions. Stoichiometry involved in sequential reactions. Once we are done with the sequential reactions, then it is going to be the time to discuss the concept limiting reagent. Limiting reagent. Please take a note of every single thing, because all these topics are super important. After limiting reagent, we shall be discussing about the percentage yield. The percentage yield. Once we are done with percentage yield, then we shall be going into the topic that is percentage purity. Percentage purity. And once we are done with the percentage purity, then it's going to be the time for mixture analysis. It is going to be the time for mixture analysis. And once we are done with the mixture analysis, right? These are the topics which we have to cover in this chapter, guys. And this is the sequence which we are going to follow, by the way, right? Take a note of all these topics. Okay? Mixture analysis. And after the term mixture analysis, then we shall be discussing about the empirical and molecular formula. Empirical and molecular formula. Okay? Empirical and molecular formula. After empirical molecular formula, we shall be starting the term laws of chemical combination. Laws of chemical combination. Once we are done with the laws of chemical combination, then we shall be starting the concentration terms. Concentration terms, right? which involves weight by weight, weight by volume, volume by volume, mole fraction, molarity, molality, normality, and parts per million, parts per billion. Right after that, we shall be discussing about the molarity of dilution. Molarity of dilution. Similarly, we shall be discussing about the molarity of mixing. Molarity of mixing of reacting as well as non-reacting solutions. And right after that, we shall be discussing about the molarity of ions. Molarity of ions. And at the same time, molarity of non-ideal solutions. Non-ideal solutions. And with this particular topic, we shall be done with the chapter. My dear students, all this table of content which I've shown you over here, I'll be completing all of this in detail in 3 to 4 sessions maximum. Okay? 3 to 4 sessions I'll be taking to complete all these topics with all the question patterns in detail. Perfect? So tell me once in the chats, have you studied these topics before? Okay, tell me, how do you want me to start? Whether you want me to start from the basics or not. Do you want me to start from the basics or you know the basics? Tell me right now in the chats. And I would want the answers from everyone. I would want the answers from everyone. How do you exactly want me to start? Everyone in the chats. Everyone in the chats. All right, got it. Got it, guys. Got it. Perfect. So this was my first question. Second question, that is personal. Where are you guys from? Can you write down your states? I just want to know from where exactly you are watching me right now. I just want to know that. Write down your states in the chats. I just want to know which state you guys are from. Quickly. Yes. At the end of the session, I'll provide the PDF of this session as well, right? In my personal Telegram. I don't know whether you guys are there in the Telegram. The name is Wassim Bhat Official, right? Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official. WASSIMBHAT Chemistry Official. That is the Telegram name, right? I shall be sharing the PDF of this particular session right after the session. Perfect. I can see majority of the students are from South, right? From Kerala, Tamil Nadu, right? Maharashtra, people are watching me. Okay, Bangalore, Kashmir. Nice, good. UP, AP, West Bengal, Telangana, Indore. That's great. So students are right now watching from across the country, yeah? Perfect, guys. So let's get going then. Let's get started and let's try to complete all these topics in detail one by one. So the first topic with which I shall be starting today's discussion, that is the basic terminologies which are involved in the mole concept chapter, right? The basic terminologies, people. Well, as you all must be knowing, the first basic terminology with which we shall start this particular chapter, that is going to be atomic mass. We are going to start this chapter from the topic atomic mass. My dear students, as I told you already, please take a note of every single thing. Whatever I'll be writing on the screen, take a note of every single thing, because every single thing is going to be super important. Trust me on that. Okay? All right. So let's get going. Let's get started with the topic atomic mass. My dear students, first of all, how do we exactly define the term atomic mass? The first and the basic definition, with the help of which you are going to define the term atomic mass. What is that? Atomic mass is defined as, the mass of one atom. Mass of one atom of an element. Atomic mass is defined as mass of one atom of an element. The mass of single atom of an element is something which you call as atomic mass. What does that mean? For example, I'm asking you, what is the atomic mass of oxygen? What does that mean? That means I'm asking you, what is the mass of one atom of oxygen? Let's say I ask you sometimes, what is the atomic mass of fluorine? What does that mean? That means I'm asking you the mass of one atom of fluorine. Sometimes I'll ask you, what is the atomic mass of carbon? What does that mean? That means I'm asking you what is the mass of one atom of carbon, right? So in short, how do we exactly define the term atomic mass? In simple words, it is defined as the mass of one atom of an element. The mass of one atom of an element is something which you call as atomic mass. This is the simplest and the basic definition. Now, my dear students, in order to understand the actual definition, in order to understand the significance of the term atomic mass, there are certain basic things which I would want to discuss with all of you. And what are those basic things? Let's have a look. Yes, it's a live session. Yes. See, guys, what are those basic things? For example, over here, I am taking certain objects. Let's say these are some objects which I'm taking over here. Object number 1, object number 2, and object number 3. I've got 3 objects over here on the screen. For example, let's say the weight of the first object over here is 5 kilograms. Let's say the weight of the second object over here is 10 kilograms. Let's say the weight of this particular object over here is 20 kilograms. So basically, how many objects have I taken? I have taken 3 objects. The weight of the first object is 5 kilograms. Second object, 10 kilograms. Third object, 20 kilograms. Now, my dear students, the objects which I have taken, since the weight of the first object is 5 kilograms, can I break this 5 kilogram as 5 multiplied by 1 kilogram? Yes, I can do that. 5 multiplied by 1 kilogram, it comes out to be 5 kg only. Similarly, can I break this 10 kg as 10 multiplied by 1 kg? Yes, I can do that. Can I break this 20 kg as 20 multiplied by 1 kg? Absolutely, I can do that. Absolutely, I can do that. My dear students, the point is, why did I break this 5 kilograms as 5 multiplied by 1 kg? Why did I break this 10 kilograms as 10 multiplied by 1 kg? Why did I break this 20 kilograms as 20 multiplied by 1 kg? There is a logic behind that. See, can I say this particular object right now, this particular object, the first object which is on your screen, the first object, can I say this object, it is 5 times heavier than 1 kilogram? Yes, I can say that. Can I say this particular object is 10 times heavier than 1 kilogram? Yes, I can say that. Can I say this particular object is 20 times heavier than 1 kilogram? Yes, I can say that. My dear students, my weight is, for example, 75 kilograms. What does that mean? That means I am 75 times heavier than 1 kilogram. So can I say I'm basically comparing the weights of different objects. I'm comparing the weights of different objects with what? With this 1 kilogram over here, right? So I took 3 objects. I'm saying the first object is 5 times heavier than 1 kilogram. Second object is 10 times heavier than 1 kilogram. Third object is 20 times heavier than 1 kilogram. I am 75 times heavier than 1 kilogram. So what exactly am I doing? I am comparing the weights of different objects with 1 kilogram, right? So can I say this 1 kilogram over here, can I say it is my reference? This 1 kilogram, it is my standard with which I am comparing the weights of different objects? Yes, I can say that. This 1 kg with which I'm comparing the weights of different objects, this 1 kg becomes my standard. It becomes my reference with which I'm comparing the weights of different objects, right? Now, my dear students, like you have got 1 kg over here as the reference with which you compare the weights of different objects, right? In chemistry, you know, you deal with atoms, you deal with molecules, you deal with ions. Don't you think in chemistry we should have a reference, we should have a standard like this 1 kg so that we can compare the weights of different atoms, molecules, ions with that standard, right? In chemistry, definitely we need a standard like this 1 kg so that we can compare the masses of different atoms or molecules with that standard, right? Okay. Now, my dear students, what is that standard in chemistry? What is that reference in chemistry with which we compare the masses of different atoms or molecules? What is that standard? My dear students, let's try to make that standard over here. Let's try to make that standard over here. Okay, let's try to make that standard over here. Let's try to make that standard over here. And in order to make that standard, what exactly I'm going to do? In order to make that standard, what exactly am I going to do? I am going to take a carbon-12 atom. In order to make that standard, I am going to take a carbon-12 atom. Let's assume this is my carbon-12 atom. Let's assume this is my carbon-12 atom. Right? Now, what exactly I shall be doing? The carbon-12 atom which I have taken over here, I am going to divide this carbon-12 atom into 12 equal parts. I have divided the carbon-12 atom into 12 equal parts. After dividing the carbon-12 atom into 12 equal parts, if I just take one part of it, can I say this shaded part? Can I say this shaded part? Its mass is going to be 1 by 12th. It is going to be 1/12 of, the mass of carbon-12 atom. It is going to be 1/12 of the mass of carbon-12 atom. So what exactly I did? I took a carbon-12 atom. I divided the carbon-12 atom into 12 equal parts. After dividing the carbon-12 atom into 12 equal parts, I just took one small part of it. And I am telling you, the mass of this small part, it is going to be 1 by 12th. 1 by 12th of the mass of carbon-12 atom. And my dear students, let me tell you over here. Let me tell you. This 1 by 12th of mass of carbon-12 atom. This 1 by 12th of mass of carbon-12 atom. From now onwards, you'll be either calling it as 1 AMU, or you will be calling it as 1U, or you will be calling it as 1D. Now, first of all, you should be knowing from now onwards, remember it from now onwards, this AMU term, it stands for, the atomic mass unit. AMU stands for atomic mass unit. This U over here, which I mentioned, U stands for the unified mass. U stands for the unified mass. And this D over here, it stands for Dalton. D stands for Dalton. So what exactly I'm trying to do? I'm trying to make a reference. I'm trying to make a standard in chemistry with which we shall be comparing the masses of different atoms or molecules. In order to take that standard, which atom I took? I took a carbon-12 atom. I divided the carbon-12 atom into 12 equal parts. After dividing the carbon-12 atom into 12 equal parts, I just took one small part of it. And the mass of this small part is nothing but 1 by 12th of mass of carbon-12 atom. And my dear students, this 1 by 12th of mass of carbon-12 atom, from now onwards, you shall be calling this as either AMU, or you will be calling it as U, or you will be calling it as D. Let me tell you, AMU stands for atomic mass unit, U stands for the unified mass, D stands for the Dalton, right? Okay. Now, people, let me tell you first of all, in chemistry, this 1 AMU, or you can call it as U, or you can call it as D. In chemistry, this 1 AMU is going to be a reference. In chemistry, this 1 AMU is going to be our standard with which we are going to compare the masses of different atoms or molecules. So the first question, if it is asked to you, what is our reference in chemistry? What is our standard in chemistry? Remember it from now onwards. The standard in chemistry, the reference in chemistry with which we compare the masses of different atoms or molecules. What is that standard going to be? It is going to be AMU, or you call it as 1U, or you call it as 1D, right? Now, my dear students, let me exactly tell you some story over here, right? What is that story? The story is pretty much simple. What scientists exactly did? Scientists calculated the mass of whole carbon-12 atom. Let me tell you, they used a technique called as mass spectrometry. What scientists did? They used a technique called as mass spectrometry. And with the help of the technique called as mass spectrometry, what scientists exactly did? They calculated the mass of whole carbon-12 atom. And let me tell you, the mass of whole carbon-12 atom came out to be 1.99 into 10 raised power minus 23 grams. Right? What scientists did? They exactly calculated the mass of whole carbon-12 atom with the technique which is what you call as mass spectrometry. So with the help of mass spectrometry, they calculated the mass of whole carbon-12 atom, and the mass of whole carbon-12 atom, it came out to be 1.99 into 10 raised power minus 23 grams. Now, my dear students, tell me just one thing. If you know the mass of whole carbon-12 atom, if you know the mass of entire carbon-12 atom, can you let me know the mass of this shaded part exactly in grams? See, this part I know, the mass of entire carbon-12 atom I got to know as 1.99 into 10 raised power minus 23 grams. If I divide this term by the number 12, I'll be exactly getting the value 1.66 into 10 raised power minus 24 grams. So if I ask you, is this the mass of entire carbon-12 atom? No, this is not the mass of entire carbon-12 atom. This is the mass of this shaded part. This is the mass of this shaded part exactly in grams. Right? Right, people? As simple as that. Now, let me tell you one more thing. The term which you got over here, this 1.66 into 10 raised power minus 24. My dear students, you can write it like this as well. 1 divided by Avogadro's number. Avogadro's number, I believe every one of you would be knowing. It is nothing but 6.022 into 10 raised power 23. Let me tell you, if you divide 1 by the Avogadro's number, what is the exact value you'll be getting? You'll be getting this as the value. 1.66 into 10 raised power minus 24. Now here it is grams, so here I'll be writing grams as well. Okay? It's pretty much simple. For example, you can write 1.5. 1.5 can be written as 3 by 2. One and the same thing. 1.5 can be written as 3 by 2. In the similar way, this particular term, 1.66 into 10 raised power minus 24 grams, right? 1.66 into 10 raised power minus 24. It can be written as 1 divided by Avogadro's number. Okay? Now, my dear students, whatever story I told you till now, I am going to summarize this entire story in just single statement. I'm going to summarize the entire story in one statement. And what is that statement? Do remember it from now onwards. 1 AMU, which is what you call as 1U, which is what you call as 1D. How exactly you defined it? You defined it as 1/12. You defined it as 1/12 of the mass of carbon-12 atom. You defined it as 1/12 of the mass of carbon-12 atom. And my dear students, the mass of carbon-12 atom was calculated to be 1.99 into 10 raised power minus 23 grams, right? Now, if you divide it by the number 12, you get the value exactly as 1.66 into 10 raised power minus 24 grams, which in terms of Avogadro's number can be written as 1 by Na grams. This is the first and the basic statement which I would want every one of you, to remember from now on. Okay, this is one simple statement which I would want every one of you to remember from now onwards. Guys, I need to turn the lights off, okay? I hope it's fine. There are some electricity issues. There is a storm, right, outside. Okay, I hope it's fine. I hope it's fine. Just a second. I hope it is fine. Yeah? Just say yes or no in the chats. Just say yes or no in the chats. I hope it's fine. Just give me a second. Let me fix these. This lighting part always is the headache to me. Okay. So I believe it's fine, yeah? I mean, you can see the screen. Dark mode is on. Dark mode is on. All right. So from now onwards, you are going to remember this particular statement. 1 AMU, which is also called as 1U, which is also called as 1D, which is defined as 1/12 of mass of carbon-12 atom, whose value exactly is 1.66 into 10 raised power minus 24 grams, which in terms of Avogadro's number can be written as 1 divided by Na grams. Okay. Now we will try to understand few things, which I'm going to tell you right now. For example, I'm writing a statement over here. I'm writing a term. The term is simple. Atomic mass, for example, atomic mass of sodium. Have you heard the element sodium? Yes, you would have heard, right? Atomic mass of sodium. What does it mean? Atomic mass of sodium, what does it mean? It means that we are talking about the mass of one atom of sodium. It means that we are talking about the mass of one atom of sodium. My dear students, you would have seen the periodic table. In the periodic table, I'm pretty much sure you would have seen the atomic mass of sodium as how much? 23 AMU. Right? You would have seen it like this, 23 AMU. Now, if I break this 23 AMU like this, 23 multiplied by 1 AMU, will it make a difference? It is not going to make a difference. This 23 AMU can be mentioned as 23 multiplied by 1 AMU. Now, my dear students, instead of 1 AMU, instead of this 1 AMU, can't I write 1 by 12th of the mass of carbon-12 atom? Yes, I can do that. Instead of this 1 AMU, can't I write 1.66 into 10 raised power minus 24 grams? Yes, absolutely, I can do that. Instead of 1 AMU, can't I write 1 divided by Avogadro's number, that too in grams? Yes, I can do that. Now, why did I do all this stuff? Just to make you understand what the atomic mass is. Have a look, people. Have a look. Try to understand. Atomic mass of sodium. What does that mean? That means I'm talking about the mass of one atom of sodium, which came out to be 23 AMU. What does it mean? It means that one atom of sodium, is 23 times heavier than what? Is 23 times heavier than 1 AMU. It means that one atom of sodium is 23 times heavier than 1 by 12th of the mass of carbon-12 atom. Right? Can I say this is the mass of one atom of sodium in grams? Yes, I can say that. Or even this term, this is the mass of one atom of sodium in grams. You can say this is the mass of one atom of sodium in AMU. This is the mass of one atom of sodium in grams. Even this is the mass of one atom of sodium in grams. Yeah? Let's have a look on one more statement. For example, people, if I write a term, atomic mass of oxygen. Tell me first of all, what does it mean? Atomic mass of oxygen. What does it mean? What exactly am I talking about? I am talking about the mass of one atom. One atom of what? The mass of one atom of oxygen. I am talking about the mass of one atom of oxygen. People, do you know what is the atomic mass of oxygen? You must be knowing it, right? It is nothing but 16 AMU. Correct? So now you can do the similar things. Can you break the 16 AMU? Yes, you can do that. You can break it as 16 multiplied by 1 AMU. You can break it as 16 multiplied by 1 AMU. Now, my dear students, instead of this 1 AMU, can't you write 1 by 12th of mass of carbon-12 atom? Yes, you can do that. Again, instead of 1 AMU, can't we write 1.66 into 10 raised power minus 24 grams? Absolutely can be done, can be written. Similarly, instead of 1 AMU, can't we write 1 divided by Avogadro's number in grams? Yes, we can do that. So first of all, what I tried to calculate, I wanted to know the atomic mass of oxygen, which all of you would be knowing, that is 16 AMU. What does it mean? What does it mean? My dear students, it means one atom of oxygen is 16 times heavier than 1 AMU. It means that one atom of oxygen is 16 times heavier than 1 by 12th of the mass of carbon-12 atom. Okay? Can I say this is the mass of one oxygen atom in grams? Yes. Can I say even this is the mass of one oxygen atom in grams? Absolutely. I'll say this is the mass of one oxygen atom in AMU. This is the mass of one oxygen atom in grams. Even this is the mass of one oxygen atom in grams. Yeah? Right, people? I believe it's clear. Right? Akib, just wait for it. I'll try to show all these questions. Just wait. I believe all these things are clear. Now, my dear students, if you try to analyze one thing, If I ask you what kind of information atomic mass is given us, what kind of information atomic mass is giving us? Try to understand. Can I say atomic mass is basically telling us how many times an atom of an element is heavier than 1 AMU? You can check it out. See, over here you can say one atom of sodium is 23 times heavier than 1 AMU. One atom of oxygen is 16 times heavier than 1 AMU, right? So atomic mass is basically giving us the idea about one simple thing, like how many times an atom of an element is heavier than 1 AMU, right? So I'm just going to write one simple statement over here. I'm just going to write one simple statement over here. I'll say atomic mass. I'll say atomic mass of an element. I'll say atomic mass of an element gives an idea about how many times an atom of an element is heavier than 1 AMU. I believe this particular statement is absolutely clear to all the students watching me right now. If this is clear, let me know once in the chats quickly. If this is clear, let me know once in the chats quickly. Everyone, people, everyone in the chats. Everyone in the chats. Is this particular statement clear to everyone? Quickly. Quickly, say yes or no in the chats quickly, everyone. Atomic mass is the term basically which gives us the idea about how many times an atom of an element is heavier than 1 AMU. It's heavier than 1/12 of the mass of carbon-12 atom. Right? Now, my dear students, there are few terms which I would want you guys to be familiar with. What are those terms? Have a look. For example, I'm writing nitrogen over here. Nitrogen, N. Nitrogen here, I'm taking in atomic form. This nitrogen over here, I've taken in atomic form. I'm just writing N. I'm not writing N2. I just wrote N. Now, my dear students, there are few things which I would want to write about nitrogen. The first thing which I'm going to write, I'll write the first term as 14 AMU. The second term which I'm going to write for nitrogen, that is only and only 14. I'm not writing any unit with it. 14, that's it. The third term I'm writing as 14 multiplied by 1 AMU. And instead of 1 AMU, I'm writing 1.66 into 10 raised power minus 24 grams. Okay. I wrote three terminologies for nitrogen. One with the unit AMU, one without the unit, one like this, 14 multiplied by 1.66 into 10 raised power minus 24 grams. Let me tell you people, this particular term, 14 AMU, you'll be calling it directly as atomic mass of nitrogen. This particular term, without the unit, you'll be calling it as the relative atomic mass of nitrogen. Right? And this particular term over here, you'll be calling it as the actual mass of nitrogen. You'll be calling it as the actual mass of N. Actual mass of nitrogen. Okay, I believe these three terms are absolutely clear to every one of you. For example, if I talk about oxygen, for example, I'm taking oxygen again in atomic form. I wrote O. I'm not writing O2. This is oxygen in which form? This is oxygen, people, in atomic form. This is oxygen in atomic form. Now, again, I'm going to write three things about this oxygen. The first term, I'm going to write 16 AMU. The second term, only and only 16. The third term, I'm writing 16 multiplied by 1.66 into 10 raised power minus 24 grams. Now, if I ask you, what is the meaning of all these terms over here? The 16 AMU, you should be calling this as the atomic mass of oxygen. The atomic mass of oxygen. the 16 without the units. You will be calling it as the relative atomic mass of oxygen. Okay, and this particular term, you will be calling this as the actual mass. You will be calling this as the actual mass of oxygen. I believe all these three terms are absolutely clear to every one of you. Yeah? Right, people? I believe these three terms are absolutely clear to you. Okay? Right, people? Perfect. All right. One simple question I'm going to give you. Let me see how much you understood from all the things which I told you till now. One simple question I'm going to give you. I'm asking you a question. Calculate the mass of 10 oxygen atoms. Calculate the mass of 10 oxygen atoms. Number 1, in AMU. Number 2, in grams. Can we solve this? Calculate the mass of 10 oxygen atoms. Number 1, in AMU. Number 2, in grams. You should be in a position to solve this. It's a simple and basic question. See, if you talk about the mass of one oxygen atom, the mass of one oxygen atom in AMU is 16 AMU. This is the mass of one oxygen atom in AMU. So what will be the mass of 10 oxygen atoms? Multiplied by 10. So it's going to be 160 AMU. Simple. It's going to be 160 AMU. 160 AMU. This is the mass of 10 oxygen atoms in AMU. This is the mass of 10 oxygen atoms in AMU. Now, you can write this AMU as, you can write this 160 AMU as 160 multiplied by 1 AMU. Yes, you can do that. Instead of 1 AMU, you can write 1.66 into 10 raised power minus 24 grams. Now, what about this particular term? What about this particular term? What about this particular term? My dear students, this particular term, this is the mass of 10 oxygen atoms in AMU. And this becomes the mass of 10 oxygen atoms in grams. Right? This becomes the mass of 10 oxygen atoms in grams. I believe it is perfectly clear to everyone. I hope the term atomic mass is absolutely clear to all of you. Okay? Right, people? All right. Perfect. So first terminology is done and dusted. Now, let's have a look on the second basic terminology. What is that? That is the molecular mass. Term molecular mass. Yeah? How exactly you guys are going to define the term molecular mass? My dear students, it's simply defined as, the sum of atomic masses. The sum of atomic masses of all the atoms. The sum of atomic masses of all the atoms in the molecule. What does it mean exactly? How do we calculate it? Let's try to understand. For example, let's say I'm taking water into consideration. Water, everybody will be knowing, right? Water. What is the molecular formula for water? My dear students, what is the molecular formula of water? It is H2O. This is the molecular formula of water. Now, for example, I'm asking you, what is the molecular mass of water? I'm asking you, what is the molecular mass of water? What does that mean? That means I'm asking you, what is the mass of one molecule of water? That means I'm asking you, what is the mass of one molecule of water? How do you calculate it? Sum of atomic masses. In water, you have got two elements, hydrogen and oxygen, right? Do the sum of their atomic masses. Start with hydrogen. For hydrogen, what is the atomic mass? 1 AMU. How many hydrogen atoms? 2 hydrogen atoms. Similarly, oxygen, how many oxygen? What is the atomic mass? 16 AMU. How many oxygen atoms? 1 oxygen atom. When you solve this, the value exactly comes out to be how much? It will be 18 AMU. 18 AMU. Now, You can either write 18 AMU, or you can write 18U, or you can write 18D. The choice is all yours. But let me tell you, preferably, we write U over here. Preferably, we write U over here. So what is this 18U? This is basically the mass of one molecule of water in U. In U. This is the mass of one molecule of water in U, which is what you call as molecular mass of water. Nothing more than that. Right? Now, people, tell me one thing. Can I break this 18 AMU as? Can I break this 18U as 18 multiplied by 1U? Yes, we can do that. Instead of 1U, can't we write 1 by 12th of the mass of carbon-12 atom? Yes, we can do that. Instead of the same 1U, can't we write 1.66 into 10 raised power minus 24 grams? Yes, we can do that. Instead of the same 1U, can't we write 1 divided by Avogadro's number in grams? Yes, we can do that. Yes, we can do that. Now check how many terms we got. Check how many terms we got. I wanted to calculate the molecular mass of water. I wanted to calculate the mass of one molecule of water. The mass of one molecule of water came out to be how much? 18U. What does it mean? It means that one molecule of water is 18 times heavier than 1U. Right? I can say one molecule of water is 18 times heavier than 1/12 of the mass of carbon-12 atom. Right? Can I say this is the mass of one molecule of water in grams? Yes. Even this particular term, this is also the mass of one molecule of water in grams. Yeah? Right, people? Simple and basic? Yes, it's simple and basic. Let me give you more examples. Let's have a look. People. Try to understand. For example, I'm writing a term over here as glucose. Glucose, everyone will be knowing. C6H12O6. For example, I want to calculate molecular mass of glucose. Let's say I want to calculate molecular mass of glucose. What does that mean? That means I want to calculate the mass of one molecule of glucose. How do you do it? Simple. Sum of atomic masses. So start with carbon. What is the atomic mass of carbon? 12 AMU. How many carbon atoms? 6. Hydrogen. What is the atomic mass? 1 AMU. How many hydrogen atoms? 12. Oxygen. What is the atomic mass? 16 AMU. How many oxygen atoms? 6. When you solve this, people, the value comes out to be 180. You can write AMU, you can write U, you can write D, but preferably you write U. Okay? Now, instead of instead of this 180U, you can break it. You can break it as 180 multiplied by 1U. Instead of 1U, you can write 1 by 12th of the mass of carbon-12 atom. Instead of 1U, you can write 1.66 into 10 raised power minus 24 grams. Instead of 1U, you can write 1 divided by Avogadro's number in grams. Right? What is the meaning of all these things? Try to understand all this in detail. My dear students, it's pretty much simple. I wanted to calculate the mass of one molecule of glucose. And let me tell you, the mass of one molecule of glucose came out to be 180U. What does that mean? That means one molecule of glucose is 180 times heavier than 1U. One molecule of glucose is 180 times heavier than 1/12 of mass of carbon-12 atom. This is the mass of one molecule of glucose in grams. Even this is the mass of one molecule of glucose in grams. Right? Right, people? I believe it's clear to everyone. I believe this is clear to everyone. Okay? So if I ask you, what kind of information molecular mass gives us? What kind of information molecular mass gives us? If I ask you, one simple question. My dear students, I'm saying, sir, please light up the background. Light up means? What are you exactly asking? Light up the background. Wow. Okay. So I was asking you basically what kind of information molecular mass gives us. My dear students, pretty much simple. Molecular mass, I'll say molecular mass gives an idea. Molecular mass gives an idea about how many times. Molecular mass gives an idea about how many times a molecule how many times a molecule is heavier than, a molecule is heavier than what? Is heavier than 1 AMU or 1U or 1D. Choice is all yours, right? So basically you got to know one molecule of water is 18 times heavier than 1U. One molecule of glucose is 180 times heavier than 1U. So basically molecular mass is again giving me the information like how many times a molecule is heavier than 1U. Right? I believe it's clear. I believe it's clear. Okay? I believe it's clear. Now, people, try to understand few simple things. Few simple things. For example, I'm writing N2 over here. I'm writing N2 over here. Okay? Over here, I'm writing N2. Or let me not write N2. Let me just write N. And over here, just to make you understand, I'm writing N2. What is the difference between the two? Right here, I wrote N. Right here, I wrote N2. Yeah? N and N2. So over here, my dear students, I can say nitrogen I took. Nitrogen I took in which form? Right here, I took nitrogen in atomic form. Right here, I took the same nitrogen in which form? I took the same nitrogen in molecular form. I took the same nitrogen in which form? In molecular form. Now, there are few things which I am going to write related to N and N2. Try to understand and grasp all the things which I'm going to tell you now. Have a look, people. The first thing which I'm going to write, I'm just going to write 14 AMU. Second term, only and only 14. Third term, 14 multiplied by 1.66 into 10 raised power minus 24 grams. Right? Three terms I wrote related to N. Here again, I'm going to write three terms. The first term, I'm writing 28U. 14 into 2 is 28. 28U. Second term, only and only 28. The third term is 28 multiplied by 1.66 into 10 raised power minus 24 grams. I want you all to be familiar with all these six terms over here. Okay? I want you guys to be familiar with all these six terms over here. First of all, nitrogen here is in atomic form. So this is something which you will be calling as the atomic mass of nitrogen. What do you call this as? This is the relative atomic mass of nitrogen. What is this particular term? This is basically going to be the actual mass. Actual mass of what? This is actual mass of N. This actual mass of N. Now, you are going to tell me, what about this 28U? Nitrogen here is in molecular form. If nitrogen here is in molecular form, then 28U, I will be calling it as molecular mass of nitrogen. This is the molecular mass of nitrogen. This 28, I'll be calling this as a relative. Should I be calling this as a relative atomic? No. A relative molecular mass. A relative molecular mass of nitrogen. Right? This particular term, you should be calling it as the actual mass. But is it the actual mass of N? No. This is the actual mass of N2. I believe these three things are absolutely clear to all of you. If yes, let me know once in the chats quickly. Let me know once in the chats quickly if all these things are clear to you. Let me know if all these things are absolutely clear to you. My dear students, same thing goes for oxygen, right? Now you should be in a position to tell me the meaning of all the terms. For example, here I'm writing O and here I'm writing O2. What is the difference between O and O2? Just tell me that. Oxygen here I'm taking in which form? Oxygen here I'm taking in atomic form. But at the same time, here oxygen I'm taking in which form? Oxygen right here I'm taking in the molecular form. Right? Oxygen here I'm taking in molecular form. Now people, you are going to let me know the meaning of all the things. See, first thing I'm writing 16 AMU. Second term I'm just writing 16. Third term I'm writing 16 multiplied by 1.66 into 10 raised power minus 24 grams. Right? Three terms. Now, 16 multiplied by 2 is 32. So 32u. Second term, just 32. Third term, 32 multiplied by 1.66 into 10 raised power minus 24 grams. Tell me the meaning of all these things quickly. Tell me the meaning of all these things quickly. Tell me the meaning of all these things quickly, people. Yeah? My dear students, pretty much simple. Pretty much simple. What do we call this as? This is going to be my atomic mass of oxygen. This term is your relative atomic mass of oxygen. This term is your actual mass of O. This term is your actual mass. Actual mass of what? Actual mass of O. Correct? Now, what about this 32U? It is nothing but molecular mass of oxygen. Right? This particular term. Relative molecular mass of oxygen. This particular term. Actual mass of what? O or O2. Actual mass of O2. Okay? I believe you will be easily differentiating all these terms from now on. Yeah? I'm pretty much sure you'll be easily differentiating all these terms from now onwards. Right, people? Right? Perfect. Now, one statement I'm going to tell you, remember that. One statement I'm going to tell you, remember that. Statement, it's simple, just remember that. Do remember, my dear students, on changing the scale. On changing the scale. What is the scale which we have chosen? The scale which we have chosen 1U as 1 by 12th of mass of carbon-12 atom. Imagine if the scale is changed. Instead of 1 by 12th of mass of carbon-12 atom, if you write 1/6 of mass of carbon-12 atom, 1/24th of mass of carbon-12 atom, what happens due to that? Remember, on changing the scale, remember it directly from now onwards. On changing the scale, actual mass of the substance, on changing the scale, actual mass of the substance, it does not change. It remains unchanged. It remains unchanged. Remember this particular statement as well. When you change the scale, on changing the scale, my dear students, actual mass of the substance, it does not change. Okay? One simple question I'm going to give you. You are going to tell me the answer of this particular question. One simple and basic question so that I can understand whether you are grasping the things or not. One simple question. Calculate the mass of 10 water molecules. Calculate the mass of 10 water molecules. Number 1. In U. Number 2. In kilograms. Oh my God. In kilograms. Okay, these are two simple questions. Let me see exactly whether you'll be able to solve them or not. You should be in a position to solve them, by the way. You should be in a position to solve them. How do people try to understand? Calculate the mass of 10 water molecules. First of all, tell me one thing. What is the mass of one water molecule? What is the mass of one water molecule? What is the mass of one water molecule? The mass of one water molecule is nothing but 18U. 18U. If the mass of one water molecule is 18U, this is the mass of one water molecule in U. So what will be the mass of 10 water molecules in U? I'll just multiply this term by 10. When I multiply this particular term with 10, I'll be getting the value exactly as 180U. This is the mass of 10 water molecules in U. In U. Okay? Now, instead of 180U, can I write 180 multiplied by 1U? Yes, I can do that. Instead of 1U, can I write 1.66 into 10 raised power minus 24 grams? Yes, I can say that. Can I say, people, this particular term, this is the mass of 10 water molecules in grams. In grams. So, if I want to convert this into kilograms, what am I supposed to do? I'm just supposed to divide this particular term by 1000, then this particular term will come in kilograms. Perfect? So this particular thing, this is the mass of 10 water molecules in U, and this is the mass of 10 water molecules in what? In kilograms. I believe all these things are clear. Right? I believe all these things are clear. Yeah? I believe all these things are clear. Now, my dear students, the first and the basic question which I'm giving you. The first and the basic question which I'm giving you. Look at the question carefully and try to understand. Look at the question. I'm looking at your chats. The question is pretty much simple, guys. As per the question, if 1U is defined as, 1 by 24th of the mass of carbon-12, what will be the molecular mass of carbon dioxide on new scale? See what the question is. I'm modifying the question. First, I'm modifying it like this. Also calculate the actual mass. Also calculate the actual mass of what? Of carbon dioxide on the new scale. See how you guys are going to solve this sort of equation, right? Remember the procedure and from now onwards, follow that procedure. My dear students, if I ask you, how did we define 1U? How did we define 1U? We have defined 1U as 1 by 12th. 1 by 12th of the mass of carbon-12 atom. This is how we have defined 1U. This is how we have defined 1U. As per the question, how they are defining 1U, which I'm calling as 1U dash. They are defining 1U as 1 by 24th. 1 by 24th of what? 1 by 24th of the mass of carbon-12 atom. This is how they are defining 1U in the question. My dear students, I'll be calling this particular equation as equation number 1. This is something I'm calling as equation number 2. So how many equations I got? I got 2 equations. The first one is the conventional scale, which we have selected. The first one is the conventional scale, or you can call it directly as old scale, which we have selected. As per the question, this is the new scale. This is the new scale. Perfect. Now, my dear students, the first thing always, whenever these sort of questions come to you, the first thing always, you are just going to divide these 2 equations. Just divide these 2 equations. If I divide 1 and 2, if I divide 1 with 2, so it's going to be 1U divided by 1U dash, or you can directly write U divided by U dash is equal to mass of carbon-12 atom, mass of carbon-12 cancel. In the numerator 1 by 12, in the denominator 1 by 24. So this value 1 by 12, 1 by 24 comes out to be 2. So I got to know U divided by U dash is nothing but 2. So, or I can say U is nothing but 2 times U dash. U is nothing but 2 times U dash. This always has to be your first step. Get the relation between U and U dash. Get the relation between U and U dash. Yeah? Get the relation between U and U dash. This always has to be your first step. Get the relation between U and U dash. Okay? Right? My dear students, after getting the relation between U and U dash, what exactly you are trying to do, what you are going to do, try to understand. Try to understand. What am I supposed to calculate? I'm supposed to calculate the molecular mass of carbon dioxide on new scale. If I ask you, what is the molecular mass of carbon dioxide on our scale, which we have chosen? We know how to do that. Carbon, it is 12 AMU, right? Multiplied by 1 carbon. Oxygen, 16 AMU. How many oxygen atoms? 2 oxygen atoms. You know, it is nothing but when you solve it, it is 44 U. This is the molecular mass of carbon dioxide as per old scale, as per our scale. But do we have to calculate the molecular mass of carbon dioxide in terms of U or in terms of U dash? We have to calculate the molecular mass of carbon dioxide in terms of U dash. In terms of U dash. So my dear students, this 44U, you can write as 44 multiplied by 1U. And instead of this 1U, instead of this particular 1U, you can write 2 times U dash. You can write 2 times U dash. The value comes out to be 88 U dash. So what is this 88 U dash? If I ask you, what is this 88 U dash? I would say, this is the molecular mass of carbon dioxide as per the scale which is given to us in the question. Right? This is our answer. Perfect. This is the scale. This is the molecular mass of carbon dioxide as per the new scale. Perfect. Now the question says, also calculate the actual mass. Also calculate the actual mass. How do we calculate the actual mass? First of all, forget about the scales. Forget about the scales. What about What about the molecular mass of carbon dioxide as per our scale? We know it. That was 44U, right? 44U. 44U means 44 multiplied by 1U. Instead of 1U, you can write 1.66 into 10 raised power minus 24 grams. This is the actual mass of carbon dioxide. Now, I made you write one simple statement a few minutes back. On changing the standard, does the actual mass change? Actual mass does not change, right? It remains unchanged. So actual mass of carbon dioxide as per new scale also will be this much. Do you get it? Do you get it? Yeah? Yes, Harshu, you can do that. Okay, do that right now and go to some other channel. Okay, I do not encourage this nonsense stuff in the chats. Okay, I hope you know it. I hope you know it. Teaching here, okay, and students are listening properly. Okay, let them listen, let them not disturb. Okay, you can go to some other channel wherein people chit chat and do stuff. Okay, so I believe this is perfectly clear to everyone. Now, people, this is the question which you guys are going to do right now. Do it. Do it right now. Do it right now, people. Do it right now. Tell me the answer. Do it right now. Similar type of question, and this is something which you are going to solve. This is something which you are going to solve on your own. You just need to follow the same procedure. You're not supposed to follow something new, right? Follow the same procedure. What I told you, how to solve the questions, in the similar way you guys are going to do. See, guys, it's a simple question. See, first of all, how did we define 1U? We defined 1U as 1 by 12th. 1 by 12th of what? 1 by 12th of the mass of carbon-12 atom. This is how we have defined 1U. Right? Let me call this equation number 1. Now, as per the question, how they are defining 1U, which I'm calling as 1U dash, they are defining 1U as 1 by 6th. 1 by 6th of the mass of carbon-12 atom. This is how they are defining 1U. I'm calling this equation number 2. Calling this equation number 2. What I'm going to do, first of all, I'm just going to divide these two equations. Divide the two equations, so you get U divided by U dash is equal. In the numerator 1 by 12, in the denominator 1 by 6, so it comes out to be 1 by 2. Okay, mass of carbon-12 cancels out. So I would say U is nothing but, it is U dash divided by 2. So my first thing is done. I got the relation between U and U dash. I got the relation between U and U dash. Now, my dear students, as for the question, what am I supposed to calculate? Molecular mass of NH3, right? Molecular mass of NH3. So, just try to calculate it. I would say molecular mass of NH3. As per old scale, it will be how much? 14 plus 3. It will be 17U. But am I supposed to write the answer in U? No. I'm supposed to write the answer in U dash. I'm supposed to write the answer in terms of U dash. So, it is nothing but it's going to be 17 multiplied by 1U, and already you know 1U is nothing, that is U dash divided by 2. So the final value comes out to be 8.5 U dash. So this is the molecular mass of NH3 as per the scale which is given to us in the question. I believe you will be easily solving these sort of questions. Let me know in the chats quickly. Yeah? Right, people? Right? Let me know once in the chats quickly. Let me know once in the chats. Akib, in order to solve that question, you should know the mass of one atom of oxygen. Okay? You should know the mass of one atom of oxygen in grams. Then we can do that. Perfect. All right. One more question I'm asking you. Tell me one thing. What is going to be the actual mass? What is going to be the actual mass of this NH3 over here on the new scale? Actual mass of NH3 on the new scale. On the old scale, how much is the actual mass? Actual mass as per old scale is 17 multiplied by 1.66 into 10 raised power minus 24 grams. This is as per old scale. So as per new scale, what will be? On changing the standard. On changing the standard, does the actual mass change? Actual mass does not change. Actual mass is still going to remain the same. I hope all these stuff, all these things are clear to you. Right? Perfect. So these were the two basic terminologies which I've discussed till now. One was atomic mass, one was molecular mass, and the kind of questions which can be asked from these two terms, right? So my dear students, today's session I'm going to keep this much only, short and precise only, right? So let's not go aggressive on day one itself. Yeah, let's not go aggressive on day one itself. Let's do things slowly because we have got a lot of time. So tell me once in the chats, if every single thing till now, whatever I've discussed, if every single thing is clear. Tell me honestly in the chat. I want an honest answer. One question I'm going to give you as the homework. Do tell me the answer of that question in the comments. And I'll exactly see how many students are basically serious about the preparation, right? I'm exactly going to see that. I'm going to see your comments. Okay, question is simple. If 1u is defined as, if 1u is defined as 1/36th of the mass of carbon to light, calculate the molecular mass, of glucose, on new scale. Also calculate the actual mass of glucose. Right? This is your homework question. Let me know its answer in the comments. Right? Let me know its answer in the comments. And at the same time, once this session ends, the session is about to end, right? I'm going to share the PDF of this particular session on my Telegram, which is Wassim Bhat Chemistry Official. WASSIM, right? BHAT, Chemistry Official. Perfect. I'm going to share the PDF of this particular session in the Telegram group. And do let me know in the comment section of this particular video whether you liked all these things, right? Whether you want me to do all the chapters like this only from the basics itself, right? Or do let me know whether you knew this thing before, you want me to go to the higher level directly. Okay? Do let me know all the stuff. Whatever you feel like, do let me know in the comments. And continuously, see, tomorrow it's going to be physics session, right? On alternate days, I'll be taking the sessions. So weekly, I'll be taking 3 sessions on this channel, right? I will try to complete all the chapters, whatever chapters I start, I'll try to complete all of them on this particular channel itself, right? In detailed format. You need not worry. In detailed format. Okay? Do let me know in the comment section of this particular video. So I'm going to take a leave with this. I'll see you guys day after tomorrow with the mole concept part 2. Take care. God bless you all and love you all, guys.